the x is the variable in the problem, the x-axis if you want. F prime is the next row, and f is the next row. And yes, and I promise you I'm not gonna add more to it except the second derivative. So please understand the table. I'm not gonna put it now because we're not gonna use it at this point, but this is it. X, F prime, F, and F double prime. I promise there is nothing else later. So I put 0 in the table, I put negative 1/6 in the table, and I put 0 under negative 1/6 because that's how we determined it. F prime of x is 0 at negative 1/6. We will also determine this function value in a minute. We're going to plug it in the calculator. I'll put it in here. So now, let's take a look at the derivative. Please plug in a number to the left of this number, like negative 10. Plug in 0 in here and give me the sign. Sign here, sign here. So to the left of negative 1/6, what would you say? Let me write it one more time. F of x equals 6x plus 1.
Let's do negative 5.
So it's negative. And what about this side?
Positive.
Yes. Remember, for a linear function with a positive slope, you don't need to plug in. This is, if you want to graph this, it looks like this, not like this, because the slope is positive. It has to come from negative values and it has to go to positive values. You should never think negative, positive. But if the slope is negative, then you should never think and write positive, negative, but only for linear functions. This discussion is only for linear functions. Good. So now I'm going to plug in and determine that number. So I'm going to share my screen, find the calculator, and clear. I like to put the function in. I like to put in 6x plus 1. It's easier for me. And then plug in negative 1 divided by 6. Okay. No, that's not what I meant. I meant the function. 3x squared, of course. 3x squared plus x minus 2. Not the derivative. We are finding the function value. We did everything for the derivative. We don't need anything else. Okay, so for negative 1/6, I get negative 2.08. I put it in the correct spot. And now you tell me, when the first derivative is negative, what does the function do? When the first derivative is negative, what does the function do?
Decreases.
Excellent. When the first derivative is positive, what does the function do?
Increases.
So this is it. This is a relative minimum. Why? Because the derivative changed sign, negative, 0, positive. So this must be a local minimum. We know that in this case, is also an absolute. First derivative negative, then 0, then positive. So this must be guaranteed to be a relative or a local minimum. In this case, because the function is quadratic, it's also absolute. It's a lot of work, a lot of analysis, but we're going to practice as much as we need. Yes, any questions? Yes.
Did we need to solve for either side with the original equation too? Because this is just showing us the same trend as the derivative.
Yes.
Or is there?
We are going to add more to this table.
Okay.
That's not it. Good question. Thank you.
Professor, I just wanted to,
yes.
I think you said it already, but for the undefined derivative or the undefined
Yes.
tangent,
Yes.
those three cases are not continuous, vertical.
No. Continuity has nothing to do with the function not having a derivative there. Please.
No. Just for the undefined derivatives. Like I'm just.
Yes,
the
it can
cases for
still
undefined derivatives.
be a local max or min. Yes.
Right. So the three undefined derivative cases are not continuous, vertical tangent, and cos. Right?
Correct. Yes, I see.
Okay.
Yes.
Thank you.
Perfect. Yes. A review of that, but very good. Okay. So I get to choose the next one. I'm going to choose an ugly one, 39. You will see why I consider this ugly. T to 3/4 minus 2 t to 1/4. Before we even do anything to it, why do you think I consider it ugly?
Fractional exponents.
Yes, of course. I have to factor out t to which power? And the answer is the smallest of the two. Yes. It's really ugly. So what do we have left? Of course, I have a -2 because -2 times t to 1/4 will be this. But what do I get from here? So from 3/4, I have to subtract 1/4. I was already calculating. So this is 2/4, which is 1/2. So this is basically t to 1/2 or the square root of t, right? So this now becomes the 4th root of t, the square root of t minus 2. Not friendly. So they're asking us to find critical numbers. In addition, we are going to discuss whether they become max or min. So what do we do? From the very beginning, for this function, I have to state domain. Here, you can say you forgot to state domain. We don't really almost never state domain for polynomial functions. We know it's this. We know the domain is all real numbers. That's why we haven't had that discussion here. But here it's a different story, right? So this is the 4th root of t, and this is the square root of t plus 2. Can anyone tell us what conditions t has to fulfill in order for this to exist, and in order for this to exist? Remember, this is index 4 and this is index 2. And the same condition apply for both.
Just be positive.
Or
An absolute squared.
positive or? I'm asking, can we take the square root from 0?
Sorry, no. No, can we?
Absolutely. 0 squared is 0.
Okay.
So one more time. If the index is even, we have to have positive of 0. If the index is odd, we can have anything. So again, what is the domain of this function? How do I write it?
T greater than or equal to 0.
Perfect. So then domain is 0 to infinity. Perfect. It's very important. Okay. So now I will get my table going immediately. Okay. Good. So this was our analysis, and we found the domain. So now let's find critical numbers. I'm going to copy the original function here. So I can put that page away. Good. So we have to find h prime of t. And then we have to set it equal to 0 or undefined. We would not be able to do this before finding the domain of the function. That's one of the reasons why we had to define the domain. Okay, perfect. So can anyone give us h prime of t? Anyone, please.
One-fourth t.
So 3/4 t to 3/4 minus 1. And then minus 2 times a quarter.
1/2 t to the negative 3/4.
Yes. Okay. Now, remember, these will go to the denominator. But before we even do that, let's continue with factoring out the greatest common factor. T to which power? And the answer is always the smallest. Which one is the smallest?
Negative 1/4.
Yes. 3/4 stays. From negative 1/4, I subtract 3/4. So 3/4 minus 1/4 is 2/4, and it's 1/2. And this is minus 1/2 because t to 3/4 is out. So now this is basically 1 over t to 3/4, and this is 3/4 t to 1/2 minus 1/2. Good. We have the derivative. We're going to set it equal to 0. So this first source, as h prime of t, is 0. The denominator cannot be 0, only this can be 0. So 3/4 t to 1/2 minus 1/2 equals 0. Or I can replace this with a square root. It's easier now. Or equals, I'm moving to the other side. I have to multiply by 4/3. So I have the square root of t equals 2/3. How do I solve this equation for t? What operator we have to apply to both sides?
Oh, the power of 2.
Yes, we square both sides, of course. So we get t equals 4/3. This is our first critical number. Is t equals 4/3 in the domain? Yes, it is. So I'm going to put 4/3 here and put 0 for h prime. Okay, next. There is a second source where this function is undefined, but the function is defined. The point has to be on the function. So h prime of t equals undefined. When will this function be undefined? Not when this does anything, but when this does something. What? When is this function undefined? When
The denominator.
t is
0.
yes. So this is critical number, and also this is critical number. But this critical number comes from h prime being undefined. I have nothing to put in here. That's why I cover it with this vertical bar. Two critical numbers for the function, for h of x. When h prime is undefined, which is at 0, and the function is defined there, and when h prime is 0, which is at 4/3. I have to find these function values now, always. So I'm going to plug this function in, and when I plug in 0, it turns out it's 0, but I have to plug in 4/3. So I'll share my screen and put it in the function, clear, I have t to power 3 over 4. And then I have minus 2 t to power 1 over 4. Good. All I want to plug in is this ugly number 4/3. And I get approximately negative 0.91. Negative 0.91. Okay. At next step, I have to find the sign of the derivative. Yes, you can say, well, from 0 to the obviously it decreases. I know. But this will not always be obvious. You will see in the next lectures. So I have to find the sign of the derivative with x equals 1 and with x equals 10. And then I'm convinced that this is negative and this is positive. So here's the derivative. I will put in the graphing calculator. I go back to y equals. That one can stay. So I will put it in as t to power negative 3/4. And then in parentheses, 3 over 4, 3 times t, or the square root, better. But okay, I wrote that already. I typed in, so 1/2, 0.5, divided by 4, and then minus 0.5. So this is the derivative, x t to negative 3/4, 3/4, 3 over 4 with x to 1/2, yes, and minus 0.5. So now all I want is the sign when, for the second function, I don't care for the first one, I only look for the second one, for x equals 1 and 10. So 1 and 10. Okay, so there is no sign change. Again, let me make sure that I enter the function correctly. So x indeed to negative 3/4, yes. And then 3/4 x to 1/2, yes. Minus 0.5, correct. Okay, so the function, the derivative, does not change sign. If it does not change sign, and it's always positive, it means that there is no max min at that point, at 4/3. So one more time, 4/3 is a number greater than 1, that's correct. So I put 1 between 0 and 1. Yes, that's correct. As I'm just making sure. I also want to make super sure that I didn't make an error. I'm going to just de-highlight that and look at the graph for a moment of this function. I'm just going to use the standard viewing window. So it's 0 at 0. It has a minimum. According to the graph, that is a minimum. So I have, again, I'm checking my calculations. We factor that, negative 1/4 plus 3/2, that's correct. That's correct, minus 1/2. It was a little bit taken aback by the fact that I don't see a sign change. I'm going to enter this differently. I'm going to enter it differently. So x to power negative 3/4. And then 3/4. I need another set of parentheses. No, not that. Negative 3/4. And then parentheses and then parentheses. 3 over 4 times the square root of x, yes, and minus 0.5. Close. Do I have enough? Yes, I have enough. Now I'm going to look again. So I'm getting 0.25. I'm getting positive both of them, but I did not expect that because obviously the function has a minimum. So I was expecting at 1 the derivative to be negative, and I was expecting at 10 to be positive, which is correct. But I was expecting the 0.25.
Professor, wasn't the derivative 1/4 x to the negative 3/4? Did I miss something?
Let's take a look.